Hello everyone, and welcome to this LoRaWAN meeting on LoRaWAN and non-terrestrial networks. So we are the LoRaWAN. We are a non-profit organization that started 10 years ago. We develop and maintain standards. We are recognized by ITU as an official international standard organization. And we are doing a lot of education about our work, and that's what we're doing now. We do have also a very complete certification program. So to start with the webinar today, some very important housekeeping notes. So the most important is you may submit your questions at any time during the webinar, and all the questions will be answered during the Q&A session in the end. These slides will be available, and so you don't need to record it yourself. So LoRaWAN expands to non-terrestrial networks connectivity, and we already have 3 commercial services running using either LEO or GEO satellites. And from the 3 companies in order they will talk today, EchoStar Mobile, Plan S, and Lacuna Space. This is really a unique position in the IoT space to have such commercial services already running. Initially, LoRaWAN was designed for terrestrial IoT networks with low power and long range. And thanks to LRFHSS, we added these new data rates to support long range and high capacity. And a satellite is no more than a gateway with massive coverage, which requires this long range and high capacity. The satellite networks also make use of other LoRaWAN specification, namely the relay specification, and you will be hearing more of that today. And the satellite networks will also use, when that part is ready, we're working on that today, the network discovery beacon. We have in the LoRaWAN a dedicated task force for satellites, which works on today regional parameters dedicated to satellites, making the world a global region for satellites. And the task force is also working on specification complements to run satellite operation. One recent news is coming from the regulation. We have a regulatory working group in the LoRaWAN, which contributed to this CPT work on setting rules for satellites in the for short-range devices, for SRD. And today there is a draft decision that will likely make to a final decision in November this year, and that decision will include a list of harmonized technical conditions for use of satellites in the 862 to 870 megahertz, including the power levels on the ground received on the ground from the satellites. The LoRaWAN regulatory working group will continue to work with CPT and will also promote this concept, this regulation outside of Europe. So this was my introduction, and now I leave the floor to Telemaco Media from EchoStar Mobile.
Thank you, Olivier, for the introduction. Good morning, good afternoon to everybody. Welcome to this webinar around non-terrestrial networks and connectivity from space. So my name is Telemaco Media. I'll introduce our organization shortly. I just wanted to start this session with work that has been going on in the LoRa Alliance for the past months, and how essentially bring connectivity to the next level from space. So this is probably you may have seen already these infographics. It's probably like 6-8 months old, but this is to witness the work that has been going on by different people that are going to talk today during this session, and combining essentially the terrestrial and the non-terrestrial aspects under a single umbrella. So if you go to the next slide, please. So who is EchoStar? A few words about who we are and what we do. EchoStar Mobile is part of a large organization, EchoStar, headquartered in the US. Is a large operator providing providing wireless broadband services as well as satellite services. Specifically, our group in Europe is focusing on providing IoT services and mobile satellite services in the license band, in the S-band. We do have, we are also testing same services in the United States, and we essentially bring direct to sensor connectivity. How do we do that? If we can move to the next slide. So yeah, and I think you have to click through exactly. Satellite connectivity up to now, as you know, of course, the IoT connectivity in general has been booming from smart buildings, smart industry, smart city. We are now getting to a place where you need to also digitalize anything that is beyond, the urban environment. And when you need to do that, satellite is really probably the only technology that provides cost-efficient coverage to get to the famous 100%, which sometimes is a very thin slice of objects, but is very expensive to achieve. And what is good for? Anything that is, digitalizing the environment, and you'll see later also with my colleagues, what can you do there? Tracking. You can track anything, whether it is persons, people, or assets. Precision farming. There is a lot going on in the forestry, for instance. Maritime, obviously, when you are not on the landmass, satellite is the only thing that can provide you continuous connectivity. And then anything that is critical infrastructure, long and skinny. Think about motorways, railways, roads, rivers, where deploying, you could deploy an infrastructure, but that is very expensive for very sparse sensors. So satellite becomes pretty handy. So that's what we call smart country. So really, how you digitalize the environment in a way that you can counteract what happened in Los Angeles, in other places, flooding. Is something that you can definitely monitor and prevent. There are a number of use cases that can be listed. Since we launched the services, we have been witnessing a lot of interest in the soil monitoring and agriculture. Utilities is going strong, and a lot in anything that is tracking and transportation. So the list is long. The truth is that often there are people coming with a problem and say, how do I solve this problem? So there are applications that we don't even think about at the beginning, simply because you don't know them. The good thing is that if you build a modular technology and something that can be integrated pretty easily and quickly in existing devices, then you really can solve problems that up to now were difficult to address. So just to give you few examples of things that we've been advertising lately. You may have read in the news, Starlink and others, Globalstar with Apple providing emergency services when you're not in coverage of cellular connectivity, text messaging, when you are not under the cell tower of your operator. There are things that obviously are happening, in competing technology in different segments, but these require a long cycle technology deployment. You need to get into the phone. Is getting there, but is not yet really reality. So what what this company did essentially was build a dongle, and there are other type of dongles out there, so it's not the first one, but it was probably the first one with LoRaWAN technology, providing SOS messaging and tracking. This can be used in remote regions, can be used for safety reasons, man down. So you can imagine, anything that requires this type of connectivity when you're not under cellular coverage. And really, the goal here is a cheap device that can, turn any smartphone into a satellite phone at the end of the day. So this is something that was pretty new in terms of having a companion based on this technology, and really the goal was to build something small, low power, and very cheap. So if you want to have a look, go on the website. Is available and is running on our network. Another use case, very much interesting, is what you can do with wildfire detection. Is a very actual conversation. There are every summer fires around the globe, and is not going to decrease. So really having the option of understanding when the fire is starting and being able to alert authorities is something that has no value, because has great value, because then you can really save money and people, considering that these fires can also be deadly. So this company Dryad, we've been working with, they did integrate our technology, and they do today deploy services in using satellite as well. It's not only satellite; they do have other means to connect to the network, but satellite is one of them. And if I'm not mistaken, they have been recently shortlisted at the GLOM Awards at the Mobile World Congress in Barcelona. So if you are there and you have the chance to go to the GLOM Awards session, please attend, and you may see them winning actually. So we hope for the best. And then I think there is one last use case, which is our trusted partner ProEasys. They do build devices for critical infrastructure. So these devices are usually, they do have complex mechanical design because they are always or often deployed in harsh environments. They do measure things like, electric lines, pipelines, and other things. So this becomes very complex when you need to deploy in terms of, what do you need to sense and the precision that you need to sense. But these devices can now be, as you can see, there is a small solar panel. They are self-sufficient. They are low power, battery operated, obviously, and then they are very easy to install from a technology standpoint. Although they are satellite based, but it's sufficient that they see the sky, and then they can procure the data that you want. So again, these are examples of devices existing today. There are more, and I think I have a slide later explaining, showing all the possibility. But this is just to show some key activities that we have been working on in the past couple of years since we launched commercially the service, and that today, you do have devices ready for deployment. If you go to the next slide, here we simply, and I guess people will get the slide, so you will be able to read, on your own. But the goal here is to explain that there is actually a module that provides connectivity, is bidirectional, is real time, and is based on the LR1120 Semtech chipset. It can provide dual connectivity both in the S-band and terrestrial band, so potentially can connect to any terrestrial system, whether this is satellite based or terrestrial based. That's why we are standardizing in the LoRa Alliance regions and satellite access mechanisms that can enable any device to actually access several overlays, whether we are talking about geostationary or non-geostationary constellations. And the goal is really to enable customers, OEMs, system integrators, device manufacturers to actually deploy and leverage existing ecosystems. So if there is already a terrestrial network, great, we will be able to use it. Once you are out of coverage, we will be able to use satellite. Or you may want to use satellite because of safety or security reasons. So there are multiple ways that you can actually deploy it. The goal is to make satellite so cheap and so easy to integrate that it becomes ubiquitous, so the people don't have to question why I need to have satellite. People will simply do it, and then if the services are commercially attractive, then our belief is that then the people will just use it at any point in time, which is really a change, a change in the paradigm up to now, because the perception is that satellite has been always complex to integrate and very expensive to operate. And that's what, from a corporate standpoint, we want to avoid, potentially hiding all the complexity of satellite and LoRa at all, and then just give people AT commands and APIs to get the data. Okay. So in a nutshell, there are different flavors of how you deploy the solution. In our case, we are using geostationary satellite, so it's a bent pipe. So we do have a ground segment where we implement a unique, because we had to build it, didn't exist, so a unique gateway, which you imagine like a super gateway that can talk to the satellite, and then obviously the whole LoRaWAN mechanics with the network server, and then providing connectivity directly to objects in licensed spectrum. Here we see MQTT connector. So basically, people are able to pick up the data from the cloud through MQTT. We do have other means to actually connect. We demonstrated and we commercializing services with Actility and Swisscom, for a true dual mode system. So Swisscom customers are able to purchase LP1 services, both terrestrial and satellite. So these type of experiments and integration have been possible because of the ability of the ecosystem of being modular and able to adapt to different customer needs. So if you are a Swisscom customer and you are looking for services, now LP1 services can be offered also through satellite. If you go to the next slide, yeah, here is a much larger run on available devices. So you can go on our website. We do have a marketplace. We don't sell ourselves devices. These are devices that have been built by our partners in different verticals and for different applications, but they do exist today. So you can, if you go on our website, you will be able to contact the manufacturer and then understand how you can get going with this type of devices. Here we see a specific reference to our module. You may have seen earlier in the year communications around EchoStar, Murata, and AVX Kyocera. We essentially have been testing the Murata 2PT module on our network in licensed spectrum, and we have been successful, and we've been able to successfully transfer uplink real-time data from the transceiver to the satellite. So the modem that we use in that case is obviously a smaller feature set of the EN2050. It provides uplink only capability, but there are a number of applications like track and trace where the need to build compact, low power, and low cost solutions is really important. So again, this shows that as operator we are open to different solutions. and integrate different type of modems. If people are interested, we do have a reference also to the press release, and then we can show you what is possible there. And I think is the last innovation that we have been pushing on the market is the ability to provide satellite connectivity to objects that are terrestrial and will stay terrestrial. The LoRa Alliance has been standardizing a very interesting feature set called Relay, which essentially enables any relay node to actually relay data from terrestrial to terrestrial, and in this case, from terrestrial to satellite. It's a battery-operated object that provides you the mean to transfer terrestrial nodes to satellite and then back to the cloud. This is very interesting for deployments where, for instance, you do have indoor meters that you will need to get connected, but they are hard to reach, or is commercially unattractive to put a gateway in that environment. So the relay will solve that problem, or where you have devices that have been manufacturer certified for specific environments, maybe like ATIX environment, and then you cannot change them. Okay, so upgrading them to have direct to satellite modems is not an option. So the relay also comes handy because is bringing satellite without actually changing the hardware of the device. You may need to upgrade the software because there is a software upgrade required to support the relay specifications, but that's all. So because we want this ecosystem to grow, we have been launching recently a relay testing program. So people will get free access to technology in their time for a given amount of time. We are looking for people, building relay and nodes, so nodes that can talk the relay functionality. So any manufacturers, OEMs that are looking at, solving problems through this technology are welcome. You can contact us, and we will discuss how to enable your testing. So as a last slide, what are the benefits of satellite and specifically our network? So we provide the famous 100% coverage, considering that we do interoperate with existing networks, and we want to interoperate with private and public networks, as we did in the case for Swisscom. We provide connectivity in remote areas. Is a very cost effective because you don't need to deploy any infrastructure at all. We do support firmware over the air upgrade. It is an important feature, especially when you go to specific segments like critical infrastructure. So we do support FWOT and multicast. They are battery operated, so people have the myth in mind that satellite will consume more, but in this case, because of the quality of the modulation itself working below the noise floor, and because of the high power satellite is in the sky, then you can actually afford to have small antennas, and the batteries is using can last for multiple years. Easy to scale, obviously, because in the moment you can integrate, and then you can add satellite, which is ubiquitous. Then the applications are many, and even today, we don't think that we've been seeing everything that can happen with satellite. And then we work with the LoRa ecosystem, which is, in terms of IoT, one of the largest ecosystem. It is very is alive. There are a lot of things happening. Is an open standard. There is a large community, many experts around the world. So it's really fantastic support for people that need to get going. And that's why we started all the collaboration in the task force to actually create a set of specifications that can enable objects to get connected to to different orbits. Doesn't matter if this is geostationary or non-geostationary, and at the same time connect to the terrestrial, so that they can really, the users can get the maximum benefit out of using a single chipset. And I think with this, I'm done, and I'm getting over to my colleague Osdemir.
Hi everyone, thank you, Telemako. My name is Özdemir Gümüşay, and I'm the Chief Technology Officer of Planes. And I will start with introducing our company, Planes Satellite and Space Technologies. We are founded in 2021, and we are a pretty young company. We started as a joint venture company of two Turkish companies called Kontrolmatik Technologies and Infinia. And we are based in Ankara, the capital city of Turkey, in Hacettepe University Technopark. And we built our own nano and micro satellites for our services. And we have been launched 13 satellites after our establishment in 3.5 years. And our mission is to improve the life on our planet through sustainable space technologies, and IoT is one of them. And our vision is to become the premier space technology company by propelling the transition to satellite-based solutions. We see lots of opportunities in space, and we see a satellite-based transition for many sectors. And in the next slide, I will talk about our business lines. We are in 3 business fields. The first and biggest one is the IoT, satellite IoT. We are delivering satellite IoT services through Connect the IoT network. And the second business line is Earth observation, and we are deploying a constellation of Earth observation called Observa. And the third one is space as a solution in which we deliver specific or tailored space solutions for our customers' specific needs. And what we are doing is we are in the satellite connectivity business. The Connect IoT network is a LoRaWAN compliant satellite system in low Earth orbit. And we optimize Connect IoT network for cost and power efficiency. These are the 2 powerful sides of our service. And in Earth observation and remote sensing, we are building, manufacturing, and deploying high resolution and very high resolution Earth observation satellites. And we combine Earth observation data with IoT data for specific applications. And as I said, we design and manufacture nano and micro satellites, especially for our IoT and Earth observation services. And we build sector-specific solutions, including IoT and Earth observation for many industries like energy, logistics, maritime, or agriculture. Yeah, I will give into details of Connect IoT network. Connect IoT network is a LoRaWAN-based satellite IoT solution. It's fully compliant with LoRa specifications in terms of frequency regulations, etc. And Connect IoT networks has a global coverage with low latency. And one of the primary requirements of this system is the cost efficiency. We provide really cost-efficient solution for many industries. And our solution is scalable and reliable in terms of using LoRa technologies and a huge LoRa ecosystem. Next slide, please. And this is the basic architecture of our system. In our system, we have 2 different links for IoT connectivity. In the left-hand side, we have what we call is a direct-to-satellite link, in which every IoT device can connect to our satellites without any relay or any device between the satellites. And in the second one, we call it as a terminal to satellite link. This is for dense deployments or existing deployments. We are using gateways to collect data from the terrestrial sensors, and then the collected or aggregated data is sent to our satellites using terminal satellite link. And we have inter-satellite link capability between our satellites to decrease the total latency. When after receiving the data, we transfer this data to the ground stations in a minimal time. And of course, we download the data to ground stations, and we push these data to Planet's core network, which is simply a LoRaWAN network. And the data in the core network is pushed to different platforms of our customers, mobile applications or web-based applications. We can use cloud services or private data centers. And I will shortly give some information about Connect IoT satellites. As I said, the cost efficiency is the main feature of our solution, and we optimized our satellites for cost efficiency. These satellites are in 6U size, and we have a very reliable solution to guarantee continuous IoT services. We have lots of technical advantages in these satellites to have a reliable solution. And we also have an electrical propulsion system here to maintain the constellation formation to guarantee the intervals between the packet receive times. And of course, we can use this propulsion system for deorbiting after the end of the life. And we have advanced radiation and single event effect protections in these satellites to guarantee the reliability of our services. And in the user side, we offer different kind of solutions or various solutions for our customers. The basic solution is called as IoT module and antenna, in which we are offering these solutions for device manufacturers. Device manufacturers can use these modules and antennas in their design to connect their devices directly to our satellite systems. And we have also solutions for IoT system integrators and end users called IoT modems. This is a family with different kind of designs, solar-powered ones, battery-powered ones, and optimized for many applications like electricity meter reading, etc. And we offer these solutions for existing deployments or for deployments that you don't want to change the design of your IoT device, or you cannot change the design. And in the terminal satellite link side, we are offering an IoT gateway. This is very similar to a LoRaWAN gateway. It is designed for our terminal satellite link services, and it can aggregate sensor data using LoRaWAN, Wi-Fi, Bluetooth, or cable connections. And the collected data is transmitted to our satellite network through satellite access terminals. This is a special design for our TTS services. It provides high capacity and ultra reliable links for IoT gateways. And we can use this solution also for applications with large data packets, tens of kilobytes. And this is a two-way communication solution. And this is our constellation plan. We have 4-phase plan to increase deploy our constellation. We already completed the preparation and POC phase last year, and at the end of last year, we started our commercial services, and up to now, we launched 8 commercial satellites into orbit, and we started giving our commercial services. And at the end of this year, we will increase the number to 16 satellites. We have 8 satellites in our clean room manufacturing right now. And after reaching 16 satellites in orbit, we will decrease the revisit time of our service to less than 3 hours. And starting with the next year, we will start our expansion phase. We will launch 72 more satellites in 2 years, and the average revisit time will be less than 1 hour. And at the final phase, we are going to have an average revisit time of less than 15 minutes. And this is the ground segment of our solution. We have 7 ground stations in use right now, the red ones. We have 3 ground stations in Turkey, and we have 4 ground stations in different parts of the world. And starting from this year, we are going to launch 7 more ground stations, and we will start with Sweden and Australia. And we will increase our ground stations to 14. Of course, we will not deploying all of these by ourselves. We are using the ground station service providers. Next slide. And we offer, of course, some user panels and dashboards for different applications for our customers. These are some examples. The dashboards or user panels are customizable for various applications. And we offer the customers can change the design according to their needs. And I will talk about some use cases and fielded applications. We started our commercial services, and we started with one of the biggest use cases in Turkey. In Turkey, there are 21 regions and 15 companies to deliver electricity, and we are working with all of these companies to read their electricity meters through our smart meter modems. And we did lots of deployments in the field in different parts of Turkey, especially in remote areas where the GSM coverage is not good enough to read the smart meters by GSM connectivity. And we did lots of analysis to see the benefit of using satellite IoT services in electricity meter monitoring. And we reduced the total cost of reading electricity meters up to 25%. And also we decreased the total carbon footprint up to 50% by decreasing the physical visits to the sites. And of course, we enhance the employee safety because in remote areas, it is hard to read these meters. The employees face different risks. They are injured or they get accidents, etc. And we provide enhanced employee safety. And we increase the operational efficiency by giving automated processes to our customers. And in the next slide, I will talk about the second use case. This is the water management use case. We started working with some partners in water management, reading the water levels or the water quality, etc. And we started deploying our modems and delivering our services to remote areas, again in dams or in riversides. And especially in old cities, the water losses may reach up to 40%. This is a huge number. And if we can detect the losses or leaks in the pipelines, then we will gain a huge amount of water. And knowing the losses and leakages at the right time will significantly lower the infrastructure maintenance costs and reduce the fuel and labor expenses. And this is a very important and very successful demonstration to our customers. And these are the pictures in the field that we are working with our partners to measure water levels in dams or the monitoring the health of the pumping stations. And in the next slide, I will talk about the third use case. We are working with solar power plant companies And at the right side, you can see a floating solar power plant in Ankara. And there is an GSM coverage problem in this region, and we are exploring the benefits of getting monitoring the generation efficiency in this power plant, and we monitor the equipment faults using our satellite connectivity. And in the next slide, I will talk about the weather monitoring use case. Weather monitoring is very important for agriculture areas or for farmers to optimize irrigation, which protects the crops and increase yields. And of course, for many other applications, we can monitor the weather using the satellite connectivity. And in the last use case slide, we are working with our partners for monitoring soil health. We can integrate sensors, IoT sensors with our IoT modems to monitor the temperature or moisture of the soil or some parameters of the oil like nitrogen, phosphorus, or potassium. And we detect the soil degradation and nutrition deficiencies and reduce the need for costly investigations and optimize the maintenance and improve the crop yields. And the next slide will show some of our partners. We are working with Murata in hardware development, and we are working with Semtech in software part, and these are our strategic partners, and we are extending our services through their markets. And in the last slides, I will talk about our Connect Up program. This is a specially designed program for domestic and international early adopters. In Connect Up, we offer price advantages for newcomers or early adopters, and we offer joint development, technical support, and joint marketing studies for various use cases in their territory or in their specific applications. If anyone is interested on Connect Up, please text to us, and we will be happy to contact you for more details. And I think this is the end of my presentation. And John from Lacuna Space, the floor is yours.
Thank you very much. Hopefully you can hear me now. So Alpa asked that we talk about something with real value as a use case. So am I going to talk about gold or Bitcoin? No, I'm going to talk about water. Water's a theme that cuts across many of the verticals that we work in. And of course, water is critical to our lives, our daily lives in every way, as you see on the screen here. In 2020 chip shortage, you may remember, one of the reasons was drought, lack of water, stopped the fabs in Taiwan. In Spain, too much water this last winter and terrible flooding. We need water for drinking, for leisure environment. So it's critical to everything. But I start with this picture to describe a use case, and we'll use the use case to talk through Lacuna so you can understand who we are, what we offer, and how you can engage with our technology. But this is a great scene to understand the kind of places we work. Water in watercourses like this tends to be in valleys that cut through deep rocks, inaccessible to radio signals, covered in dense vegetation, as you see here. Even if there was a terrestrial network in this area, it really would struggle to penetrate into this environment with horizontal signals. And the other aspect of this picture is there's no population here, there's no people, there's no infrastructure, buildings, power. These are the kind of places that we work, and these are the kind of places where your typical public networks, cellular networks, or LoRa networks as well, would not proactively build a network here. And this is the key advantage for satellite, and these are the kind of environments we work in. As we move to the next slide, you'll see that this first one was quite picturesque and beautiful, but unfortunately, we don't treat our watercourses particularly well. It's not difficult, sorry, to find slides like this in the news and documentaries describing the kind of pollution that we put into these rivers. So we see here sewage overflows in storm events on the top left. On the top right is fertilizers from farmland being washed into the watercourses. Bottom right is an industrial outlet, and bottom left is nutrient-rich outlets, which causes algae blooms within the water. And I think you can agree, none of us would want to bathe and certainly not drink this kind of water. But if you hit one more time, Chansey, of course, the natural environment doesn't get the choice. They live in these environments and must be protected. So we've been embarking on a project which we want to talk about today in Wales with Ceredigion County Council. If we move to the next slide, we can get a perspective on this. So Ceredigion County Council includes the Teifi River. This is in mid-Wales. And this map you see on the screen spans about 120 kilometers. So the river flowing from the tributaries in the top right towards the coastal outlet in the bottom left. And the councils are now responsible for managing the environment and the pollution levels in these rivers. This is from global legislation that passes down to national legislation, which passes down to local authorities. And these county councils are the competent body that has to manage this process. And they are actively doing this. And this map shows that they break down the region into catchment areas. So along the length of this river, 120 kilometers, it's broken down into 38 catchment regions. And you can see there from this lovely picture of the tributary rivers, how they flow in from those regions towards the river and discharging to the coast. So it's an important perspective on the kind of applications we address, because think of the density involved here. So 38 data monitoring points spanning across an area, well, a length of 120 kilometers. And as seen in the previous picture, very difficult environments, deep valleys, deep vegetation, hard to get signals. So even if you had a terrestrial network here, you could expect pretty short range, which means to connect across 120 kilometers would probably take, I don't know, a couple of dozen gateways, but certainly you would only get the benefit of a couple of sensors per gateway, which really becomes uneconomic. The council already embarks on this process. They're already taking these measurements. If we move to the next slide, you'll see some data. And actually, Wales is very proactive on this. They actually have public data cubes where they publish this, so you can find the data yourself on this link. But they are currently doing manual sampling. It's a very manual process where ecologists go to the field, they take test tubes of water from the river, and they collect it and take it back to the labs for processing. And this is what they've lived with so far. And the results on the top of the screen really highlight the difficulties in this. So there are temporal gaps. I didn't include the raw data, but looking at the raw data you can see on that link, the time between measurements, on some occasions, it's within a month from one measurement to the next. And then there's a gap of 6 months or more before the next data is taken. In the context of agricultural fertilizer runoff into rivers, you could miss an entire season within a 6-month window. So that temporal gap is a significant problem. There's also delays. If you look at the top of the image, this data set, which is the current live data set, was data gathered in 2017 to 2019. It is due an update any day now, but I believe the new data only brings it to 21. So even on the day it's published, it's 4 years out of date. The council have tried cellular connectivity to connect these regions, and it just has not worked. Wales is also very proactive on LoRa networks. There's a huge amount of LoRa coverage that exists within several regions of Wales, mainly supported by the councils. And this also failed because of the difficulties of terrestrial coverage. Maybe half of the points that they wanted to measure were just not capable of being done with terrestrial gateways. So this is where we joined the project. They already had established the partners for the chemical sensing. They already had their own dashboards and databases and so on, and they needed Lacuna to step in and bring the data back. If we move to the next slide, you'll see how we do that. So this is exactly the scenario that we're warning of. LoRaWAN coverage is fantastic in the smart cities. It's where they've deployed those networks, where the population exists and where the industry exists. But it leaves these unfulfilled use cases in remote areas, exactly as we've demonstrated here. If we move to the next slide, Chansey, you'll see how Lacuna addresses this. So we pick up data from those remote sensors that were previously out of coverage. We collect it to the satellites, we bring it back to the ground station, much as has been described by the previous presenters. And we route that through our platform into the existing network. So that's an important point, that Lacuna is not asking our customers to take a backward step to disassemble their existing LoRaWAN coverage or to change their network server from one vendor to another. We're compatible with the entire ecosystem, and we create hybrid networks where we can ingest our data into the existing terrestrial networks. In this case, the County Council was using the Things network, and we ingest the data through the packet broker. And that could be any of the existing networks on the LoRaWAN ecosystem, Actility and ThingPark. It could be Laureate, Chirpstack, AWS, Orbywise. Any of these would work through back-end interfaces. So if we quickly move to the next slide, Chansey. So looking at the devices that we offer, it's really amazing what these devices can do. This is our standard reference design. It's about the size of a beer mat, 8 by 8 centimeters. It contains a suite of sensors for proof of concepts and to get people started. But really, it is mind-blowing to think this small device can really communicate 1,000 kilometers to LEO satellites. And it really is virtually the same as terrestrial LoRaWAN devices. So we use the same frequency bands, we use the same power levels. So really 14 dBm can travel 1,000 kilometers to a LEO satellite. That gives you the same battery life. And because we use the same radio chips and protocol stacks, then really it's the same cost basis as any LoRaWAN device that you're familiar with out there. The key differences are that we, of course, have an upward pointing antenna to get to the sky. And that defines really the size of this device. We use LR FHSS modulation, which is now part of the LoRa Alliance technical specifications and regional parameters. We won't go into the technical details of LR FHSS today, but Olivier has done fantastic videos on this, published on the LoRa Alliance channels that you can look up. But the key point is LR FHSS is critical for capacity. So these satellites looking down on the ground, they have a footprint in the order of hundreds of kilometers, 500-600 kilometers. And of course, you can have millions of devices within that footprint. So the capacity is really critical to be able to scale. And then finally, at the application layer, we add a library, which is really there for low power optimization. And that's a library that keeps the device in sync with the constellation. So we broadcast all the ephemeris data from the constellation through an almanac file. The devices interpret this, and the library tells the device exactly when it needs to wake up. So it sets the alarm clock, goes to sleep in super low power mode, and wakes up just at the right time to send data. There's a small asterisk here. I said it uses the same frequency bands. That's true on LEO satellites, where we use 868, 915, 923 megahertz. We also use S-band, which happens to be on MEO and GEO satellites. It's not technically linked to those orbits, but it just so happens that those satellites historically use S-band. If we move to the next slide. So we are compatible with the entire ecosystem again, using modules from the marketplace. This is not an exhaustive list, but just a list of typical modules that we have worked with using LR FHSS. In the picture here, you see a workshop. This happens to be using a Murata evaluation kit with a Murata module and running Murata software. You can just see we added the Lacuna sub-gigahertz antenna. And we didn't add the library in this workshop. We just told the user the exact time to press the button. So the user was the almanac. And we had 20 people connecting to the satellite within an hour. So this just shows how accessible the technology is. If we flip to the next slide, we can actually see here, this is the deployment of these water sensors in the use case that I described before. This is actually the first location, the first test site where we deployed. And the men in yellow there are the sensor provider, a company called Clearwater. They're leaders in phosphate and nitrate chemical sensors, which are very high grade and low drift sensors. These had already been selected. They were already trying to get the data back through various routes, and they were finally resorting to memory cards to bring the data back. And you see Jamin, our engineer, deploying the first unit there, setting it up with keys and everything to get up and running. If we move to the next slide, you'll see that just a little bit more detail. And this is a great example of how you can adopt our technology. So in the slide earlier, I showed the complete unit in plastic. We do also offer that as an antenna module. So instead of individual modules, as we showed before, this is the radio module attached to the antenna with the microcontroller and the stack and everything needed to manage the satellite communication. So we take out the box, we use the antenna module, and in this case, because we were interfacing to existing sensors which happen to use RS485 interface, and we didn't have that on our antenna module, we use this intermediate board, which is the purple board you see there. This is a hardware developer's playground. It's an expansion board that really brings out all of the headers from the antenna module and makes them accessible on more industrialized connectors. So you can see there micro E click headers or Seed Studio Grove headers, and there's positions for different batteries, different solar chargers, and this kind of thing, to put together solutions like this very conveniently and easily. So you see that that complete assembly there, but within the box of the sensor manufacturer, who happen to already have solar panels and large battery banks that we could just tap into and collect the data. If you move to the next slide, we can actually see how that looks more in a fully optimized mass-produced device. This one is actually a soil sensor. Similar kind of discussion on the environment that this works in. Sensors spread over millions of hectares. It would not be economic to bring a LoRaWAN gateway or a network to cover this application. But I think you can recognize there from the shape of this soil sensor, you can see where the antenna would sit in the top section, and then there's a probe from the bottom which just pushes it into the soil. So this is what we work towards with our customers. We enable them with easy to address starter kits and developer kits to get started, and we work hand in hand to bring them to fully integrated devices that they can build themselves on market pricing. But not only is that a technical marvel with the amazing ability to reach 1,000 kilometers to LEO or 10,000 kilometers to MEO satellite, but I want to mention the significant commercial advantage that this offers. By using satellite here, of course, you completely decouple yourself from terrestrial infrastructure. So LoRaWAN has always had the advantage that you don't need to rely on public networks. You can if they exist. And where they don't exist, you can bring your own gateways and build your own network. but it's not always economic. And if you're a solution provider who just wants to ship anywhere under the sky and know that you'll get a connection, satellite really gives you that massive commercial advantage. So as we move to the end, if we flip to the next slide, we can just say that we provide global coverage. We operate LEO satellites in polar orbits, which scan out the whole globe. In fact, all of the oceans here should be painted purple as well, but then you wouldn't see the map so easily. And in terms of our readiness, our commercial readiness, you can see we're well covered in Europe. We're very strong in Latin America and Australia, and we're making great progress into Africa, which is more of a fragmented continent in terms of the regulations. And you'll also notice that the US is not colored purple. We're having a slow time with FCC in terms of being a European entity entering into the US market. And so I would open up an invitation to any of our partners who want to be a satellite operator in the US. We can enable you to do that. If we move to the next slide, just a final word on the technology and the portability of the technology and the focus of Lacuna. So we got into this business back in 2016. You may remember early days of people declaring they've reached 100 kilometers, 200 kilometers, 400, 700 kilometers. This were the early founders of Lacuna proving the technology on weather balloons and similar before launching the first satellite in 2019. So we base our satellites on a super powerful software-defined radio, implementing LR FHSS in software. As mentioned before, that's critical for the capacity of the system. And we make this software-defined radio and this space-proven gateway available to other vendors as well, other constellation operators. So Lacuna is investing in LEO and particularly sub-gigahertz connectivity, and that's the purple circle at the core of this. We have onboarded partners in MEO orbits with S-band and bent pipe architecture. We have tested in GEO, but we don't currently have a partner in GEO. So again, the invite is open for other GEO partners there. If they want to enter the IoT market, Lacuna can enable that. And then all the way to the left, of course, we have this interoperability with the terrestrial sub-gigahertz LoRaWAN ecosystem. And if we move to the final slide, just a recap that the system is available, the service is available, it's global coverage. We can bring back your data 4 times a day, 2 times a day, 1 time a day. These are typical applications we focus on. All of the constellations I mentioned on the previous slide, whether they're Lacuna satellites or satellites hosted by our partners, all of the data comes back through the Lacuna network, and all of the data is included in our accounts to our users. So you get the benefit of all of those aggregated constellations. Our unique proposition compared to legacy satellite operators is the open source, easy accessible nature of it. And your data will be delivered back to your own network servers in the order of 2 or 3 hours each day. So that's the end of my section. That's the end of the 3 presentations. So now we can move to the Q&A portion of the webinar.
All right, thank you, John. Thank you, everyone, for the presentation. Thank you, Ozdemir and Telemaco. So I'm Julian Catalano. I'm the LoRa Alliance Technical Committee Vice Chair, and I'm also the Deputy CTO for Kerling. So I will be hosting the Q&A session. So we have many questions in the Q&A section. So I will start straight with the question about the technical questions first. And the first one was on the relay from Michal. And it's on you, Telemaco. Can you explain us if we can use terrestrial relay with unlicensed band towards the satellite?
Yeah, so as you know, the relay specific. Well, first of all, thank you everybody for listening the webinar until the very end. Yeah, the relay, you know, has been standardized in the LoRa Alliance as terrestrial relay. I think EchoStar and also Lacuna have been proposing satellite-based relays. I think the difference between what EchoStar offers and what Lacuna offers is that in our case, the relay works with terrestrial ISM towards the end nodes and then is using licensed spectrum to talk to the satellite. While in the case of Lacuna, and I will let John confirm, is that they are using terrestrial, you know, ISM bands both for terrestrial and satellite operations. I don't know, John, if you want to add something more on top?
Yeah, if you hear me okay. We actually support both. So yeah, ISM on the terrestrial side could also be Bluetooth or other technologies. And then on the relay to satellite side could also be ISM or S-band.
All right, thank you. Thank you. So we have another question from an anonymous reader. Do all LoRa devices use LR-FHSS for uplink data transmission? And does it work on any frequency spectrum, John?
So yes, we do use LR-FHSS on the uplink, and that's for capacity, as mentioned in the slides. CSS does also work, but it would run out of capacity too soon. We use CSS on the downlink, which is essentially multicast because capacity is not a concern there. So yeah, it works across all the bands, sub-gigahertz and S-band the same.
Okay, thank you. And we had a question, similar question from Richard on LoRa chirp spread spectrum modulation. So is it used in any satellite solution today, presented today, or is it LR-FHSS only? Maybe Ozdemir, you can tell us more about that.
Yeah, so the answer is similar to John's answer. We are using LR-FHSS in the uplink direction.
Right.
For the capacity or the scalability of the service, and we are utilizing chirp spectrum in the downlink side. Yeah.
Great, thank you, thank you. So we have other question about latency of satellite link. So maybe I will ask first on the geo part for Telemaco. What's the latency and does it impact the LoRaWAN class A downlink? So that's a question from Javier.
Yeah, no, in the case of geostationary solutions, the satellite is fixed in the sky at 36,000 kilometers, so it's not moving. So that offers you the opportunity to have bidirectional real-time communication. So it means that you can run over-the-air activation. And then obviously you also have a downlink. So in terms of LoRaWAN specifications and operation with existing class, no, there is no impact.
Okay, maybe John, can you tell us the same on orbital orbits? And we have also a question from Michelle, which is also talking about specifically for Southeast Asia, but I guess that's the same for the full planet for LEO.
Yeah. So on the polar orbit LEO satellites, as mentioned in a slide a few minutes ago, it's a store and forward architecture, whereas Telemaco talks about bent pipe, which is real time in S-band. But in the store and forward architecture, the data is literally uplinking to the satellite and traveling across the sky on the satellite before finding a ground station and coming down. So there is an automatic latency built in. And I think the interesting part of the question is if you're in a hybrid mode where some packets are catching a terrestrial network and some packets are going on this store and forward satellite architecture, they can arrive to the network server in the wrong order. So on the frame counter, you could get out of order frame counters, which on some implementations of LoRa network servers, they have strict counter order, and it might reject those latent messages that come in late. And in other implementations, it's less strict, and so it's no issue. But it is something that we manage on our data routing hub to make sure things arrive in the correct order.
Thank you, John. Thank you. So we had one more question on the technical side about security, and I see that more are coming on the compliancy of LoRaWAN. So one question was from an anonymous again. What's the specific security consideration for the satellite-based LoRaWAN? So maybe we can have one question for LoRaWAN first. Maybe Ozdemir, can you tell us what's the security? What's involved in security?
Yeah, well, actually, our solution uses the security specifications of LoRaWAN protocol, and this is one of the reasons that we choose LoRaWAN in our solution. We are providing the same security levels, the same security protocols within LoRaWAN protocols.
Okay, thank you. Telemaco, could you tell us more about the implementation security, maybe?
Yeah, there is one aspect which is the LoRaWAN protocol itself, and then there are other aspects which are more related to operations and how you really, manage the keys. So in our case, we decided to use the secure element that is actually embedded in the 1120 chipset from Semtech, which means that there is no manual transfer of keys. Everything is derived at runtime, leveraging what Semtech has been proposing as a service between the joint server and the key management system. So there are aspects related to the protocol, as Ozdemir was saying, and there are aspects related to operations on how you make more secure the key management.
All right, thank you. So we have many questions, so I'm speeding up a bit. I hope you can make it over time. So we have a question on use cases also. So there is one question from Wafik, who was asking if we have a way to track people who go in the wild using a personal tracker using satellites. I want to Ozdemir to answer this one.
Actually, we are looking for some products to track people in many use cases, but for tracking people, you need an real-time connection or a very low revisit time. Currently, we are providing, or our services can support a revisit time of around 3 hours or 5 hours, and maybe next year or after next year, we are going to reach to a revisit time of less than 1 hour. Then we will be offering devices or solutions for people tracking. Yeah.
All right, thank you. And one for you, John, from Javier. Do you have any device for cattle monitoring?
Yeah. I mean, it's a common use case. Many of these devices that I was showing on the call have GPS and be suitable for that. But normally our route to market is to work with customers to make bespoke devices. So we don't have one specifically in a cattle format, but we work towards that.
Thank you, John. So now we have many questions on coverage. So I will not ask them all completely because we have many countries. So Ecuador, we have Brazil, a question for South America, we have questions for Africa. So maybe you could explain us more about coverage in general. So I will start with Gio again with Telemaco, and then I will switch to Leo. Telemaco, tell us more about coverage. How do you plan to cover more than Europe and US? Do you have any plans?
So yeah, for EchoStar Mobile today, we cover all European ground from from north to south, east to west in Europe, covering also the North Sea and the Mediterranean Sea. We do cover also the border of the Northern African coast. The problem is getting licenses in specific countries that have a very tedious administration. But Europe is fully covered. We have pre-commercial services available in US, which is essentially the sister system of what today is working in Europe. So always geostationary, bidirectional real-time communications. And then there are plans for global coverage, but that cannot be disclosed yet. So for now is Europe plus working on commercial availability for US.
Okay, so John, can you tell us about coverage and revisit time?
Yeah, so there was a question there, particularly about Brazil. I can say we're live and commercial in Brazil today, so there's no waiting for that one. And just for interest, that is using licensed S-band in Brazil. That's the first to get licensed there. I saw also questions about Southeast Asia. We have trials ongoing all over Southeast Asia in various countries, but in most cases there we're looking for partners and we're addressing the regulators to get authorization in those countries, which is quite normal practice, is to go to the regulator and show some traction within the country and some engagement with local users.
Okay, so I will ask the same to be fair to Özdemir about coverage.
Yeah, since we are working in LEO and we are in orbits in polar orbits, we have a full coverage, the satellite coverage. But in order to work in a specific region, we need to get the required licenses to downlink the data, because we are using the ISM frequencies or SRE frequencies. These are license exempt, but for downlink, we need to get the required license. For now, we are licensed in Turkey, and we are working to extend this coverage, the license coverage, to many other jurisdictions like Azerbaijan and some countries in MENA and in Africa. And now we are working hard on some Latin American countries too. Yeah.
If I may jump back in, I'd also just make reference to there's some very good work ongoing within the LoRa Alliance regulatory committees, where all of us are working together in collaboration to bring this together. Yeah,
thanks, John. That's a nice addition. One more question about on coverage is one anonymous question is line of sight between the node and the satellite required for proper communication? Maybe, John, while you are on screen.
I would default to yes. That's what we always recommend. I mean, you sometimes get lucky if it's on a window shelf and the signal gets through, but for planning, we would say you need to have line of sight.
Okay, and I missed one from Joyanta, one of my ex-colleagues. Can you please specify the coverage area of satellite footprint? So I guess it differs from LEO to GEO. Can you tell us more, Özdemir, on the footprint of your satellite? How large is it?
Yeah, well, the satellite's footprint is, how can I explain? The size of the satellite footprint is almost 2/3 of the complete Turkey region.
Okay.
And of course, when you go up in the GEO, then the coverage will extend. Maybe Telemaco will explain it more.
Okay, Telemaco, can you tell us what size is your coverage and maybe some specificities?
Well, the satellite, the geostationary satellite is one in the sky and doesn't move, and then is projecting a set of what we call beams on the ground, in a given region. So the specificities of the geostationary system is that you have a beam forming technology, which is essentially seen as a lot of large cellular cells displayed from the satellite down to Earth. That's the way it's working, and then the beams pattern depends on how the system is configured. It can be of several hundreds of kilometers per beam, with a different color scheme for frequency reuse and so on. So it's a sophisticated system, but works pretty well with LoRaWAN.
Okay, thank you. Now we have a bunch of questions on software development. One, as a software developer, John, could you tell me how one would get started with developing LoRaWAN and device that is capable of satellite communication?
So our default starting position is always to recommend our quick start kit, because it's a known good device and you're not having to debug everything at the same time.
Right.
So those are available to buy. And customers normally get started with this known good device, get the experience of using the satellite, and then go into the open source software and can start experimenting and changing things or transferring it onto their own hardware and doing all the deltas from one to the other.
Okay, and one more question on that from Wafik. How easy is it to integrate a normal sensor and render it satellite ready? Anyone can take this one?
It's very convenient, very easy. I mean, this is kind of our normal daily work with customers is to make that conversion from terrestrial to satellite. And as mentioned in the slides, the satellite version of a sensor has maybe 90% the shared DNA with terrestrial sensor. There's only a few differences that we work on to make that connection, but we can have users up and running in no time at all, within an hour's workshop connecting to satellite.
Great. Thank you.
Maybe just a comment, Julia. There is an activity going on in the LoRa Alliance to make sure that, to standardize the way LoRaWAN devices should behave to get connected to satellite, whether we talk about LEO, MEO, or GEO. So if people are curious to understand how that works, I mean, they can happily join the satellite task force.
Great. Thank you. Thank you, Telemaco. That's indeed important. Well, I have one last category. Before we start the last one, we have a bunch of questions on pricing and cost. So we won't discuss the price of each solution today, but please feel free to contact their presenters on their bio. There's a bio in the front page of this webinar, so they will be happy to answer, but they won't share that publicly. But we still have question on operations, and the first one maybe for you, Özdemir, is what is the power consumption of a LoRa satellite modem?
Yeah, and these satellite modems, or the I2 modems that we call, are the devices that that sleeps in their most of life. And we are using a method in which every device calculates the satellite passes, and up to until that time they sleeps. And while sleeping, the power consumption is in microamperes, very low, small numbers. Then after the calculated time arrives, it wakes up and waits for the satellites to send beacons, and in this period it only receives, and the power consumption is again very small in terms of microamperes. Then when the satellites arrives and the device receives a beacon signal, then it sends the packages, and it took around a couple of seconds, and during this period the power consumption is around 150 milliamperes. And the DNA of our solution is to make the devices as much power consumed as possible. And the total power consumption is so small, and it can support the battery life up to 5 to 10 years.
Great, thank you. Thank you. So there are so that was a question from Nick. The next one, Andrew and Samir actually asked almost the same question about cost of deployment and also the OPEX of the satellite connectivity with LoRaWAN compared to terrestrial. So maybe Telemaco on this.
But look, satellite is very convenient when you need to deploy sparse sensors in a large geographical area. Okay, we don't pretend to use satellite in smart cities where probably you already have the availability of terrestrial networks, or to deploy satellite where you have a very high concentration of sensors in a small geographical area, like a private network, like campus and so on. So satellite is very handy when you have usually remote sensors or long and skinny infrastructure that needs to be monitored, like or pipeline, motorways, railways, where you will need to deploy a gateway. Technically, it's feasible because you may have the fiber actually running along the rail track. But then, you have a gateway for a few sensors that is very expensive. You need to maintain the backhauling, you need to operate. So, in all these conditions, using satellite is much more convenient. Now, if you need to compare, we did some analysis in the early days, but this really depends, on the type of gateways you are deploying, whether, it's rugged, industrial, and the data rate that you need to support. But clearly, in this condition, is more convenient using a satellite sensor, especially because all these sensors are dual mode, so they can connect to terrestrial. When there is terrestrial, they can connect. We will need to run maths on a specific use case, and it's not really the place to do it. But as a general rule of thumb, when you have these type of sparse deployments, then yes, satellite makes sense.
Great. Thank you very much, Michael. One last question for you, John, and it's a question for Tushar, who says, how can we compare standard gateway and device infrastructure versus satellite? So that's something we already addressed, but maybe on capacity, data latency, and minimum device sending interval, that's something more specific.
That's still quite broad, though. Capacity,
right.
I suppose we've covered this in terms of the footprint. We talked about the footprint of the satellites being hundreds of kilometers, and that led to what Telemaco just said about low density deployments. But we do have a super high capacity gateway in the satellite. I mean, it's essential in order to serve such a large footprint. And I guess the compromise that we make in order to make this cost, because these satellites, as you see behind me, they are very, very expensive gateways, but you can cover the whole planet with just a few. And so the compromise is latency. That's how we bring this down to a very reasonable cost to address the IoT market.
Okay, and I think we covered most, if not all, the questions. So I want to thank you all, John, Telemaco, and Ozdemir, for your presentations and for the time you took for answering the questions. Thank you all for listening, and see you in the next webinar. Bye-bye.
Thank you.
Thank you. Bye-bye.